going to work on the circle properties. This lecture do not involve the solving of the questions. This is a lecture on the concept, which involves the chapter number 10 and chapter number 13 of the new syllabus mathematics 7th edition. The mathematics book, which we, that's D3, the book we use for the O-levels, the books which we use for preparation of the O-levels. And this is D3, new syllabus mathematics 7th edition. It's chapter 10 and 13, which are about the arcs, the sectors, the segments, and the chapter 13 is about the angle properties of the circles. So today I'm going to try to explain you the concept of these two things. So let's start and let's learn how this works. So let's go to our slides. So so the very first thing which I want you to understand is that it's a circle, and this is the center of the circle. So this perimeter or the boundary of the circle is known as the circumference. So this point here is known as the center of the circle. So each point on the circumference is equidistant from this point O, which we call center. If you join the center of the circle with any point on the circumference, that length, that line segment is called the radius. So this OA is basically radius. If you join 2 points on the circumference in such a way that they pass through the center, then that is known as diameter. And for example, here AB is the diameter, and this AB length will be equals to 2 times the radius. The diameter is basically 2 times the radius. So this is a radius and this one is also a radius. Okay, if you join 2 points and they do not of the circumference with each other, and they do not pass from the center, we call that line segment chord. So AB is a chord. For example, here the CD is also a chord because it's not passing from the center. You have joined 2 points on the circumference with each other. So CD is also a chord. In the same way, EF is a chord. Okay. Whenever you draw a chord, the circle is divided into 2 parts. This portion, which looks smaller, it is called minor segment. And this portion here is called major segment because it's a large portion. It's a larger portion. That's why. So when you draw a chord, the circle is divided into 2 portions, and each portion is a segment. The smaller one is called the minor segment, and the larger one is called the major segment. Here again, you can see we have a circle. This is the center. The CD is a chord. So whenever you draw a chord, the circle is divided into 2 parts. So this one, because it's smaller, is known as the minor segment. And this one, this piece is larger. So this is known as the major segment. So now, if you have, a circle and you draw 2 radius like this, like you cut a piece of pizza. So this is known as a sector. This portion is also known as a sector. This portion is smaller, so this is known as minor sector. This portion here is bigger, larger, So this is known as the major sector. This angle here at the center, we say this is the angle subtended by the minor sector at the center, is theta. And this angle here is subtended by the major sector at the center. I'm calling it phi. So if you add these two angles, their sum will be always 360. Here is another example that we have drawn two radii. So the circle is divided into two parts. Each part is known as a sector. The smaller one is called a minor sector, and the bigger one is called a major sector. So angle subtended by the minor sector is suppose theta, and the angle subtended by the major sector is phi. So their sum of these two angles will be 360. Here is another example of the same thing. So here you have drawn two radii. This one is a radius, this one is a radius. So they have divided the circle into two parts, two portions. One is the small part, is known as the minor sector. One is the big slice of the pizza, and that is known as the major sector. Here is the angle subtended by the minor sector at the center. Let me say it's theta. And this is the angle subtended by the major sector at the center. Let's say it's phi. So theta plus phi will be 360. It's a very important property. Okay, so you can see that here again, we have drawn two radius. So the circle has been divided into two portions, minor sector and the major sector. The minor sector subtends an angle theta at the center, and this one's the major sector subtends angle phi at the center. So if you want to find out this arc is ACB. This is the arc of the minor sector. So its formula will be theta divided by 360 2 pi r. If you want to find out the arc of this major sector, it will be arc ADB, and its formula will be phi divided by 360 2 pi r. If you want to find out the perimeter of any sector, the formula will be radius plus the arc. Okay, here is another example of the same thing. So here you have made two radius. So it has divided the circle into two portions. This is the minor sector. This is the major sector. Angle subtended at the center is theta. Angle subtended at the center is phi. So if you want to find out the arc length ACB, formula will be theta by 362 pi r. If you want to find out the arc length ADB, which is the major sector's arc, and maybe call it the major arc also, phi by 362 pi r. If you want to find out the perimeter of this sector, the formula will be the radius plus this arc. In the same way, if you want to find out the perimeter of this big sector, major sector, its formula will be radius plus its arc. Okay, here again we have a third example of the same concept. So if you have drawn this is the radius, this is radius. The circle has been divided into two portions. One is called the minor sector. The other one is known as the major sector. If you want to find out the arc, this smaller arc ACB, minor arc, the arc of the minor sector, the formula will be theta by 362 pi r. If you want to find out the arc of this major sector or the major arc, the formula of the arc ADB will be phi by 362 pi r. Hopefully you understand. Now, so now again, you can see we have a circle, here we have a radius and radius. Circle has been divided into two portions. One is the minor sector, one is the major sector. If you want to find out the area of this minor sector, ABC, actual name is OABC, the formula will be theta by 360 pi r square. If you want to find out the area of this major sector, the formula will be phi by 360 pi r square. In the same way, we have this example. We have a circle. Here we have two radius, OC and OE. So they have divided the circle into two portions. One is minor sector, the other one is the major sector. So if you want to find out the area of the minor sector here, so its angle at the center is theta. So the area of the minor sector will be theta by 360 pi r square. And if you want to find out the area of the major sector, the formula will be phi by 360 pi r square. Here, these two angles, their sum will be 360. Here is another example on the same concept. Here you can see a radius and radius. The circle has been divided into two portions. This is the minor sector. This one is the major sector. The angle subtended by the minor sector at the center is theta, and the area subtended by the major sector at the center is phi. Area of the minor sector will be theta by 360 pi r square. Area of the major sector will be phi by 360 pi r square. The formula is basically same. So theta plus phi here is 360. These two angles, if you add them, they will be equal to 360. Now, so once here we have a circle, and here I have drawn two radius, and here I have drawn a chord AC. Now you see that when you draw a chord, the circle has been divided into two portions. This shaded portion is known as a segment, and this upper portion, the whole thing, is known as major segment. This one, the shaded one, is the minor segment. For example, if you want to find out the area of this minor sector, the procedure is very simple. You see, you find the area of this minor sector, first of all, and then from this area of the sector, subtract the area of this triangle. So you will get the area of this minor segment. So area of the sector minus the area of the triangle. So it will be theta by 360 pi r square minus 1 by 2 into r into sine of theta. Hopefully you understand. Here is another example. So here I have drawn this chord CE. So it has divided this circle into two portions. This shaded one is a segment, minor segment, and this, the rest of the thing, is a major segment. So if you want to find out the area of this minor segment, the formula is find the area of this minor sector, and from it subtract the area of this triangle, and that will give you the area of the segment. So area of the sector minus area of the triangle, theta by 360 pi r square minus 1 by 2 into r into sine of theta. A third example on the same concept. So for example, here we have drawn a chord GF. So it has divided this circle into two portions. This one is the minor segment. The rest of the thing is a major segment. If you want to find out the area of this minor segment, then find the area of this sector, and from this area of the sector, subtract the area of this triangle, you will get the area of the segment. So area of the sector minus area of the triangle, theta by 360 pi r square minus 1 by 2 into r into sine of theta. I hope you understand. Okay, so, and then the next thing is, if you want to find out the area of the major segment. So here, I have this chord AC. So it has divided the circle into two portions. This one is the major segment, and this one is the minor segment. So if you want to find out the area of this major segment, you will have to find out the area of the major sector and then add the area of this triangle in it. So the area of the segment ADC will be area of the sector plus the area of this triangle. The angle subtended by the major sector is phi. So, and the angle subtended by this triangle here is theta. So it will be phi by 360 pi r square plus 1 by 2 into r into sine of theta. So here is another example on the same concept. So here we have a chord EG, and that chord EG has converted, divided that circle into two portions. This shaded one is the major segment. This unshaded is the minor segment. We want to find out the area of the major segment. If you want to find out the area of the major segment, then the procedure is simple. Find the area of this major sector and add the area of this triangle in it. So area of the sector plus the area of the triangle. So phi by 360 pi r square plus 1 by 2 into r into sine of theta. Here is another example. For example, I have drawn this triangle IK. Sorry, I have drawn this chord IK. Circle has been divided into two segments, minor segment, and this whole is the major segment. If you want to find out the area of the major segment, find the area of the major sector and add the area of this triangle in it. So it will be phi by 360 pi r square plus 1 by 2 into r into the sine of theta. I hope you will never forget this formula. Okay, so then we have the angle properties. Okay, so now we are going to these were the properties which previously we up to the page number 8. These properties are related with the chapter number 10 of the D3 New Syllabus Mathematics 7th edition. Now we are talking about the chapter number 13 of the New Syllabus Mathematics 7th edition D3, and this is about the angle properties of the circles. So for example, we have a circle here. This is the center of the circle, and we have a chord AB. And we suppose that the line coming from the center onto the chord, that line is OX. If that line makes 90-degree angle with the chord will be bisected. Bisected means that that chord will be divided into two equal parts. So if the OX is perpendicular to the AB, OX is the line segment from the center, and the AB is basically a chord. So if the line segments from the center makes 90-degree angle with the chord will be bisected. The chord will be divided into two equal portions. So again, here's the same property. For example, this is a chord CD. Here is the center O of the circle, and the OY is the line segment from the center. And if this line segment makes 90-degree angle, if it makes 90-degree angle with the chord, if OY is perpendicular to the CD, the chord, then the chord will be bisected. It means that dy and the YC, they will be equal to each other. The chord is bisected. Here's a third example on the same property. That, for example, you have a circle, you have a chord in the circle. The name of the chord is FE. The line segment coming from the center onto the chord OZ, if the OZ makes 90-degree angle with the FE, if the line segment from the center is perpendicular to the chord will be bisected. It means that the chord will be divided into two equal portions. It means the FZ and the EZ, they both will be equal to each other in length. Hopefully you understand. Okay, now the same property, if a line segment coming from the center bisects the chord, then the angle between the chord and that line segment will be 90 degrees. If the chord is bisected, for example, this is the chord AB. If it is bisected, means the AX and the BX, they are equal. And this has been done by this line coming from the center. Then the angle between the chord and the radii and this line segment from the center, this will be 100% 90 degree. Here is another example on the same concept. For example, this is the chord, and the line segment coming from the center is OY to the chord, and it has bisected the chord. Then this means that this angle here, OYC or OYD, this angle will be 90 degree. It will be perpendicular to the chord. The OY will be perpendicular to the chord. Okay. So again, a third example on the same concept. And for example, the FE is a chord and OZ is a line segment from the center to the chord. And if this line segment bisects this chord, means it divides this chord into two equal parts, then the angle between the chord and that line segment will be of the 90 degrees. So these are the first two properties of the circle.